Alright, now we're finna do the interval of convergence. And it's basically the same steps as finding the radius of convergence. Convergence is just an extra fourth step. So let's I'm gonna just rewrite the steps out for you. So first step, ratio test. Second step, set it less than 1. Third step, isolate x. Fourth step, plug in, check endpoints by plugging them in. So let's just do it. First we do the ratio test. So that becomes x minus 8 to the n plus 1 over n plus 1. And I'm going to do this really fast because we know how to do the ratio tests, right? And if you don't, it'd be really good to practice it. I'm running out of room. I'm just going to erase all of that. So just make sure you remember those steps. Sorry, I ain't got no room. Yes, first just do the ratio test. And you should remember these steps, so it's good that I'm erasing it, so it gives you time to, like, actually memorize what's going on. Over x minus 8 over n. I'm going to do this really quickly. The n's cancel out. That becomes infinity over infinity, which is just 1. The 3 n's cancel out, so you're just left with negative 3 to the first, which is just 1 over 3. And then, so you're just left with a negative 3 in the denominator. I mean, sorry, yeah, just not 1 over 3. That just comes to negative 3 to the first power, which is just negative 3, and that was in the denominator, so. And then you got that, cancel out, just becomes x minus 8. If you're confused on how I got any of that, it's just a ratio test, so yeah, just ask me, because I really went through that fast and didn't explain my steps, but I think we're kind of good with, well, I'm good at ratio tests. If you're not, you need to get good with it. Okay. Doing a lot of yapping. Okay, so we're going to set this equal to, less than 1, like we did with the radius of convergence. So it's basically the same steps, right? So we're going to times this by negative 3. The next step was to isolate it. Negative 3. And when we divide or multiply by negative, we always flip the sign. So that becomes 3 x minus 8 of negative 3. And then you add 8 on both sides. So this gives you 11 x 5. And these are our endpoints that we're going to check for convergence. So if you remember the original equation, we had x minus 8 to the n over n of negative 3 to the n. So the fourth step is plug in endpoints and simplify. Simplify. Can't write nor talk today, guys. Endpoints and simplify. That's my and I'm going to rewrite it so you're not confused on what that is. Okay. So now let's do that. So we're going to plug in 11. 11 minus 8 is 3 to the n. So we left with 3 to the n over n of negative 3. And this becomes a negative 1. So you're left with a negative 1 to the n over n. We know by the alternating series test that this converges. So 11 converges. We're including this one. That's why it's so important to just like memorize like the functions. I mean, not the functions, the series that do converge, because you can use it for comparison tests. And you can also use it for this. Now we can plug in 5. And I just erase the dang equation. 5 minus a is negative 3, so you get negative 3 n over negative 3 n times n. These cancel out, just become 1 over n, and we know that this diverges. So this endpoint right here is going to diverge. So this is included, this one is included, this one is not included. So yeah, that's our answer. We would just do the right endpoint converges, so 11. 11 to, I think this is how you wrote it. Don't quote me on this. I forgot how the brackets look. And I don't know if these are switched. So yeah, but that's basically how you do it. And that's the second concept, so you don't need anything else. So basically you just do the steps I told you. Ratio test, set it less than 1, isolate x, and then you have this fourth step, plug in endpoints and simplify and see what function you get. And that function should tell you if it diverges or converges. If you have any questions, Chelsea, let me know, girl. I got you.